So I want you to just imagine a scenario for a second.
Okay.
You're sitting at your desk, right? And you have this idea for a massive, complex software application.
Like a consumer app or?
No. We are talking about something enterprise grade. Like it needs to be highly secure, it needs to handle payment processing, and, it has to scale to millions of concurrent users without breaking a sweat.
Oh, wow. Okay, so a massive lift.
Exactly. And in the old paradigm, and by old I mean literally just a couple of years ago, you would have to go out and secure millions in venture capital.
Right.
You'd hire a team of like 50 specialized engineers, and then you'd wait maybe 2 years just to see a functional beta.
If you're lucky.
Yeah, if you're lucky.
Yeah.
But in this scenario, you just sit down at your computer on a Tuesday afternoon.
Okay.
You start talking to it. You literally just describe the architecture, the features, the specific edge cases you need handled, to the fail-safes. Then you can get a cup of coffee.
Sounds nice.
Right. And by dinner time, that entire application is built, it's rigorously tested, and it's deployed to the cloud. Flawlessly.
I mean, it feels like the premise of a sci-fi novel, Like where humanity has just completely transcended labor.
It really does.
Yeah.
But the wild part is, we're looking at a dispatch from the near future today. A deep dive into the archives of the tech blog Netizen from mid-2026.
Yeah, and this isn't just a speculative tech review either.
No, not at all.
Yeah.
This is the exact, literal reality that a $60 billion mega deal is attempting to unlock right now.
Which is just a staggering number to even say out loud.
It is. And the articles we're unpacking today, they read like a blueprint for this impending era they're calling the Age of Abundance.
Right.
The archives are surrounded by these incredibly ambitious concepts, things like Himalayan compute, Lumina AI, and this is my favorite, building trillion-dollar sun.
Which really tells us the author is viewing the tech landscape not as, a series of isolated product launches. It's an accelerating, cohesive march toward a radically different baseline for human capability. We are basically moving from a world of constrained execution to unconstrained generation.
Okay, let's unpack this, because the catalyst for our deep dive today is one specific monumental event detailed in this source material.
The acquisition.
Exactly. The acquisition of the AI coding startup Cursor, which is also known by his corporate name, AnySphere by SpaceX, and by extension, Elon Musk's XAI ecosystem.
Yeah, this is the deal that essentially reshaped the entire board.
Totally. We're going to dissect what the demand for stockfish-level coding actually entails, both physically and mathematically. We'll tear down the schematics of mid-2026 autonomous agentic AI frameworks.
And then we'll extrapolate out to 2031.
Yes, to see what the day-to-day reality of human knowledge work actually becomes in 5 years.
And you really can't isolate any of those pieces, right? The $60 billion valuation only makes sense if you understand the gap between current AI benchmarks and, generalized computer use.
It's so true.
Yeah.
So let's start with the sheer financial gravity of this deal, because the mechanics here are just fascinating.
They really are.
June 16th, 2026.
Right.
SpaceX exercises an option to acquire Cursor for $60 billion in an all-stock transaction.
All stock.
All stock. But the timing is what makes me stop in my tracks here. Because this happens merely days after SpaceX pulls off a historic, record-breaking IPO that values the company at an astronomical $2 trillion.
Yeah, the sequencing of those events is everything. Like, the source points out that SpaceX had secured this acquisition option back in April of 2026.
Okay.
And the terms were highly unusual. So SpaceX could either buy Cursor outright for $60 billion later in the year, or they could walk away from the acquisition.
Oh, wait, didn't they have to pay a massive fee if they walked away?
Exactly. They could walk away, but they'd have to pay $10 billion strictly for collaboration work.
That is an enormous hedge. $10 billion just for the privilege of working together.
Right, just to collaborate.
I mean, that's the valuation of a highly successful unicorn startup just to be friends.
It's unbelievable.
But let's look at the asset they acquired for the full 60. Because Cursor is like the leading AI-powered code editor.
Yeah, millions of developers literally live inside it every day.
Right. It's deeply embedded in half of the Fortune 500, and the source notes reports of a $1 billion plus annualized run rate.
Which makes it a battle-tested behemoth.
For sure. But what I find really brilliant, and almost ruthless, to be honest, is the short change question the source raises about how this was paid for.
Ah, the IPO pop.
Yeah. SpaceX locked in the $60 billion price tag in April before they went public. Then they have this massive IPO pop. They become a $2 trillion juggernaut.
And they exercise the option paying in their newly minted, highly inflated public stock.
Yes. Didn't they essentially short their own pre-IPO valuation to get a massive discount on Cursor?
I mean, it certainly invites that scrutiny, right? From a purely financial mechanics perspective, SpaceX deployed freshly minted public equity at what looks like a staggering bargain relative to their new market capitalization.
Oh, yeah.
Had the acquisition been negotiated post-IPO, the Cursor stakeholders might have captured significantly more of that valuation expansion.
It's just brilliant corporate maneuvering. You lock in the sticker price of the house, wait for the currency you're going to pay with to double in value, and then hand over half as many bills.
Exactly. But even with that dynamic, I mean, the Cursor team is still walking away with life-changing wealth.
Oh, absolutely. Nobody's crying for them.
Right. And, perhaps more importantly for engineers, they get unparalleled access to resources.
Right. That's the real trade-off. They get integrated into the Colossus-scale compute infrastructure.
Yeah, Colossus being xAI's massive, industry-dwarfing supercomputer cluster.
So they get to co-train a new model to be released across Cursor and Grok. They basically trade maximal financial upside for maximal technological acceleration.
Precisely. But we have to ask why SpaceX and xAI needed to make this catch-up play in the first place.
Because in mid-2026, xAI has the raw horsepower, right? They have the compute. They have the Grok models.
Right, they have the brain. But pure model providers, the companies just building the underlying AI, they have a massive blind spot.
Which is?
They lack sticky distribution. I mean, if you're building a massive language model and you're just putting it up on a web chat interface, you are entirely disconnected from where the actual work happens.
Oh, I see. It's like building the world's most powerful, rumbling V8 engine, but realizing you forgot to design a steering wheel.
That's a great analogy.
Cursor is the ultimate steering wheel.
Exactly. The environment where developers practically live is the IDE, the Integrated Development Environment. By acquiring Cursor, xAI isn't just hoping developers will occasionally copy and paste code from a Grok web window into their workspace.
Right. They want to be the workspace.
They instantly own the workspace itself.
And owning that workspace unlocks the real prize, which is the telemetry. The source really emphasizes this. This bolts xAI's infrastructure directly onto a battle-tested application layer.
Yeah, the data pipeline is incredible.
Because if you are a developer using Cursor, every single time you hit Tab to accept a code completion.
Or every time you delete a suggestion.
Right. Every time you highlight a block of code and ask the AI to refactor it to run faster, that interaction is captured.
And that telemetry is the lifeblood of the next generation of models. We're talking about reinforcement learning from human feedback, or RLHF.
Okay, break that down for us real quick.
So when an AI generates 3 ways to sort a database, and an elite senior engineer at a Fortune 500 company consistently picks option C and maybe tweaks one variable, that is an incredibly dense, high-signal data point. You cannot scrape that from public GitHub repositories.
Because public repos just show the finished product, not the thought process.
Exactly. You can only get that signal by watching developers work in real time. So by buying Cursor, xAI essentially buys a monopoly on the behavioral data of millions of top-tier engineers.
Wow. Which fundamentally shifts how you, as a listener, should think about the AI race right now. Because having the smartest foundational model is just table stakes at this point.
Yeah, the baseline?
The ultimate leverage is owning the human-computer interface. Because the interface feeds the telemetry trains the model, and the model improves the interface.
It's a closed-loop flywheel.
Yep.
And it basically locks competitors out.
That is wild. If software is the infrastructure of the modern world, and AI is going to build that software,
then controlling the dominant coding AI platform is arguably the highest leverage choke point on the planet.
Man. Okay, so that covers the how and the what of the deal. But the why is tied to a very specific superhuman target.
The Musk tweet.
Right. On June 16th, the very day the acquisition was finalized, Elon Musk tweeted, and I'm quoting here, AI will achieve stockfish-level coding and generalized computer use.
And the invocation of stockfish there is highly, highly deliberate.
Yeah, it's a very specific benchmark of capability. Most of our listeners who follow tech probably know Stockfish is the open-source chess engine that essentially ended human supremacy in chess.
Yeah, it completely changed the game.
But I want to dig into how it does that, because the contrast with language models is striking. Stockfish doesn't just play well. It operates in a completely different paradigm.
Right. To understand the canyon between human grandmasters and stockfish, we just look at the ELO rating system.
Okay.
The absolute best human players max out around a 2800 ELO. Stockfish, running on standard hardware, routinely hits 3,500 and above.
That's insane.
It is flawless. But the mechanism is what matters here. Stockfish relies heavily on deterministic search algorithms, things like Minimax with alpha-beta pruning.
Right, so it evaluates millions of potential board positions.
Exactly. It calculates 20, 30, 40 moves deep, assigning a rigorous mathematical evaluation to every single possible future state of the board.
So it's looking at a finite, closed system. The chessboard has 64 squares, the pieces have fixed movement rules, and there is a mathematically provable state of checkmate.
Yeah, there's a defined end state.
So it can just brute force the future.
Yes.
But a large language model generating code is fundamentally different. It's probabilistic. It's predicting the next token based on statistical weights. It's guessing.
Precisely the tension. When Musk demands stockfish-level coding, he is demanding deterministic, mathematically provable flawlessness from a system built on probabilistic guessing.
Wow.
He is envisioning an AI that doesn't just suggest helpful boilerplate code, but one that can architect complex software with elite speed and zero defects, far beyond human physiological limits.
But the source text grounds us in the mid-2026 reality of where we actually are against that benchmark.
Yeah.
And looking at the data, it's a massive spectrum.
Yeah, it's not quite there yet.
Right. On the lower end, you have what the article calls saturated benchmarks. Things like human eval, which just asks the AI to write a simple function based on a short text description.
Or LiveCode Bench, which pulls competitive programming problems from platforms like LeetCode.
Like interview questions.
Exactly. On human eval, frontier models are hitting 90 to 98% pass rates on the first try. That test no longer tells us anything useful.
It's solved.
Completely solved. And even on the harder LiveCode Bench, top models are in the high 70s and 80s.
But those are highly contained environments. It's the equivalent of asking a chess grandmaster to solve a mate in two puzzle.
Yeah, the parameters are known.
Right. The real friction and the real meat of this article comes when we look at SWE Bench, and specifically SW Bench Verified. Let's break down what this actually tests, because it seems to be the great filter for AI capabilities right now.
Okay, so SWE Bench takes human-curated issues directly from real existing Python repositories on GitHub.
So real-world problems.
Very real. It doesn't give the AI a neat little puzzle. It gives the AI a massive, messy, real-world code base and an issue ticket, maybe a bug report about a database connection dropping under specific loads.
Yeah, that sounds awful to fix.
Right. The AI has to autonomously navigate the file structure, understand the dependencies, locate the flaw, write the patch, and produce code that passes the repository's existing unit tests.
That is infinitely harder. It tests multi-file edits, code-based navigation, and deep context. And yet, mid-2026, the source notes that models like Claude Opus Variants and GPT 5.5 are scoring around 80 to 88% on SWE Bench Verified.
Which sounds incredible.
It really does. That sounds like we are knocking on the door of stockfish level performance.
It does, until you look at the absolute hardest benchmarks.
Ah, right.
The article cites SWE Bench Pro, SWE Bench Live, Terminal Bench, and Mirror Code.
What makes those so much worse?
These involve multi-week tasks, completely novel environments, and what are known as polyglot code bases. And on these tests, the scores just plummet off a cliff down to the 20 to 50% range.
Wow. Let's pause on polyglot code bases for a second, because I think this perfectly illustrates the drop-off.
Yeah.
If you're building a modern web application, you don't just use one language.
Oh, never.
Right. You might have a back-end database running on SQL.
A server-side logic layer written in Python.
And a front-end user interface written in TypeScript and React. So a single bug might require understanding how a data type defined in the SQL database gets serialized by the Python backend and then rendered incorrectly by the TypeScript frontend.
The cognitive load required to trace that logic across 3 different syntaxes, 3 different frameworks, and 3 different execution environments is immense.
Yeah, that's hard for a human.
Extremely hard. So when an LLM fails here, it's failing at long horizon reasoning. It is brilliant at localized tactics, finding a null pointer exception in a single Python file.
Tactics versus strategy.
Exactly.
Yeah.
Designing a scalable architecture from scratch, or troubleshooting an elusive memory leak across a massive polyglot system over several days, it loses the thread.
Okay, I see the limitation. But wait, so if these models are still failing 50 to 80% of the time on the hardest multi-week real-world tasks, how far away are we really from this flawless stockfish reality?
That's the billion-dollar question.
I mean, isn't there a massive gap between catching a bug and inventing a novel algorithm? The source uses the analogy of an inconsistent grandmaster.
Yeah, I love that framing.
Right. The models are brilliant pair programmers. They catch routine bugs at superhuman speeds. But if you let them run autonomously for 3 days on a massive legacy codebase, they will eventually hallucinate a library that doesn't exist or fundamentally misunderstand the business logic.
And the whole house of cards collapses.
Exactly.
Which brings us directly to the solution the industry is pursuing, because scaling compute alone, just building a bigger colossus, might not bridge that gap.
Right, because more compute on a flawed paradigm just gives you faster mistakes.
Exactly. If brute force next token prediction is failing at long horizon strategy, you have to change the paradigm of how the model interacts with the problem. You have to move to agentic workflows.
Okay, this is where we transition from a tool to a worker.
Yes.
We aren't just talking about a smart autocomplete knife that chops vegetables perfectly when you hold it.
Right.
We're talking about hiring an autonomous digital sous chef.
Great analogy.
Right, a system that looks at the pantry, realizes you are out of carrots, opens a terminal, runs a command to order more, preps the station, and then asks you to taste the soup before serving it. The source calls this the engine room of mid-2026.
Yeah, agentic coding requires the AI to break out of a single text generation window. It creates an autonomous loop of planning, executing, iterating, and testing. It requires multi-step reasoning.
So walk me through the actual mechanism of an agentic loop. Let's say I ask the AI to build a simple web scraper, but the website has recently changed its structure.
Yeah.
How does the agent handle that compared to a standard LLM?
Okay, so a standard LLM generates the scraper code based on its training data, hands it to you, and stops.
Okay.
If the website changed, the code fails and you have to figure it out.
Right, which is annoying.
Very. An agentic framework uses a React loop reasoning and acting.
React. Got it.
The agent writes the code, then it uses a tool to open a sandbox terminal. It autonomously runs the script.
Oh, it runs it itself.
Exactly. The terminal spits out a stack trace error because the HTML structure changed. The agent then reads the standard output, injects that error message back into its context window, reasons about the failure.
Like, oh, the div class price no longer exists.
Exactly. It's now product price.
Mm-hmm.
Then it rewrites the code and runs it again. It loops continuously until the test passes.
Wow. It's literally simulating the trial and error process of a human engineer.
Yes.
And the source breaks down the landscape of these frameworks, highlighting very different philosophies on where this agent should live.
Right.
Cursor, which just justified a $60 billion price tag, takes an IDE integrated approach.
Right.
They have their proprietary composer model. You stay inside VS Code, your familiar environment, and you run parallel agents. You have inline diffs, meaning you see the exact lines of code the AI wants to change, highlighted in red and green, before you accept them.
And the philosophy there is keep the developer in the cockpit, but give them a highly competent crew.
Right.
You contrast that with Anthropic's Claude Code, which is a terminal-first command line interface running Opus 4.x.
Okay, so no graphical interface, really.
Right.
Yeah.
It tops the SWE bench leaderboards, but it operates differently. It's geared toward developers who want to orchestrate long-running workflows directly from the terminal, treating the AI less like a co-pilot and more like an independent process.
Interesting. Then you have OpenAI's Codex and Copilot Agent Mode, which emphasize sandboxed execution and deep integration into enterprise GitHub workspaces.
Yeah, a very enterprise-focused approach.
And then we absolutely cannot ignore the open source movement here.
Oh, for sure.
Tools like Aider, which is phenomenal for executing complex multi-file terminal edits while perfectly preserving your Git commit history. Or Clyline, which is an open source VS Code extension doing similar heavy lifting.
The article also touches on general orchestrators, frameworks not explicitly built just for coding, but adapted for it.
Like LangGraph.
Yeah, LangGraph, which allows you to build stateful, cyclical workflows where the AI can remember what it did 3 steps ago. Or Crew AI, which enables role-based, multi-agent teams.
I love the multi-agent concept. You literally instantiate a virtual software company on your laptop.
Basically, yeah.
You assign one model,
Yeah.
the persona of a senior solutions architect. Its only job is to break your prompt down into 20 small Jira tickets.
Right?
You assign another model to be the junior developer who actually writes the code for each ticket. A third model is the QA tester who actively tries to break the junior developer's code.
I love that part.
And a fourth is the security auditor. They debate, they iterate, and they only present the final code base to you when all 4 agents reach a consensus.
It is incredibly powerful, but it also highlights why Cursor's specific IDE-based approach is so highly valued right now, because there are fully autonomous, cloud-based agents. Devon by Cognition is the famous example.
Oh yeah, Devin.
Where the philosophy is, give me a prompt and I will go away for 3 days and build it.
Right. Hands off.
Hands off. The risk there is compounding hallucinations. If Devon makes a slight logical error on day 1 and builds days 2 and 3 on top of that flawed foundation,
The entire output is useless.
exactly. Cursor keeps the human intimately in the loop.
Human in the loop, or HITL. The source emphasizes that this isn't just a transitional phase.
Right.
It's a structural necessity for a while.
Absolutely.
And the reason for that ties back to a phrase in the article, semantic correctness.
Yes, this is crucial. Passing a unit test proves the code executes without crashing.
Right.
It does not prove the code solves the business problem.
Okay, let me make sure I'm mapping this correctly. Let's say I ask the AI to write a function that calculates an employee's annual bonus.
Okay.
And the AI writes a script that gives everyone a flat $10,000.
Sounds nice for the employees.
Right. Now, that code might compile perfectly. It might pass a unit test that simply checks if the output is a number. Technically, it works.
But
Semantically, it just bankrupted the company because it violated the complex, nuanced business logic of tiered performance metrics that the AI didn't fully grasp.
exactly the issue. The agentic frameworks can handle the syntax, the API calls, the boilerplate, but they still require a human orchestrator to define what correct actually means in the messy reality of human commerce and ethics.
The human provides the semantic boundary.
Exactly.
So we have this perfect storm brewing in mid-2026. You have SpaceX and xAI deploying Colossus-scale compute. You have the $60 billion acquisition of Cursor to monopolize the interface and harvest the telemetry.
Right.
You have the maturation of agentic React loops. What happens when you combine all of these elements and hit fast forward?
The big extrapolation.
Yeah, the Netizen article doesn't just stop at analyzing the deal. It takes a massive swing and extrapolates exactly 5 years into the future. Let's look at the 2031 extrapolation, autonomous software architecture.
The baseline projection they offer is staggering. They estimate that by 2031, AI will handle 70 to 95% of all production code.
95.
Error rates on well-specified tasks will drop below 1 to 2%. We are talking about a fundamental rewiring of the global economy's engine.
If 95% of code is generated by AI, the world of 2031 is practically unrecognizable.
Completely.
The source provides 5 distinct use cases for how this plays out, and I want to dive deep into the mechanics of each one because this is where the abstract concepts really hit reality.
Let's do it.
Use case number 1, enterprise legacy modernization.
This is perhaps the most economically impactful one. Imagine a massive Tier 1 global bank. Their core transaction engine, the system that actually moves money between accounts, was written 30 years ago in COBOL.
Yikes.
The original engineers have all retired, the documentation is lost, the code base is a fragile monolith, millions of lines long.
So in 2026, migrating that to a modern cloud-native microservices architecture written in Go or Rust is a nightmare scenario.
It requires hundreds of engineers, it costs tens of millions of dollars, and it carries a massive existential risk of system downtime. If you screw up the migration, transactions fail. The bank stops banking.
Right. But in 2031, the dynamic shifts.
Mm-hmm.
The human architect doesn't rewrite the code.
No.
The human architect defines the constraints. They prompt the AI orchestrator. We need to migrate this COBOL monolith to a Kubernetes-managed Go microservices architecture. Crucially, you must guarantee transaction atomicity, ensure strict PCI compliance for credit card data, and maintain sub-millisecond latency.
Now, let's define transaction atomicity really quickly for anyone not deep in database architecture, because it's a perfect example of semantic correctness.
Okay, yeah.
Atomicity means a transaction is indivisible. If I transfer $100 to you, the system must deduct 100 from me, and add 100 to you.
Right.
If the system crashes in the middle, it has to roll everything back. It cannot deduct the money from me and then fail to give it to you. The money can't just vanish into the ether.
A human understands the catastrophic, real-world consequences of violating atomicity.
Exactly.
So in 2031, the AI agent ingests the entire COBOL code base, maps every single logical dependency, generates a phased migration plan, rewrites the modules into Go, generates millions of simulated transactions to aggressively test for atomicity failures.
And prepares the deployment. What used to take a human team 3 years of agonizing, high-risk labor takes a swarm of AI agents 3 months.
That is just incredible. Okay, use case number 2 shifts from the monolithic enterprise down to the individual, the startup MVP to scale.
Yeah, I love this one.
If you have an idea for an app today, say, a highly personalized fitness coach that uses your phone's camera to analyze your deadlift form, correct your posture in real time, generate dynamic meal plans, and process monthly subscriptions.
That's a lot of features.
It is. Today, you need a front-end UI developer, a back-end database engineer, a mobile specialist for iOS and Android, and an incredibly expensive machine learning engineer just to build a prototype.
But in 2031, the solo founder is the entire team. They sit down at the descendant of Cursor. They describe the application in natural language. They feed the AI a few wireframe sketches they drew on a tablet.
Wow.
The Agentic system provisions the cloud infrastructure, sets up the Stripe payment gateway, implements the computer vision models, writes the front-end React Native code, and even AD tests the marketing copy.
Are you kidding?
A polished, scalable version 1 goes live in days, entirely bypassing the need for $1 million seed round just to build the product.
The barrier to entry just vanishes. Okay, use case 3. Scientific software. We are talking about researchers at the bleeding edge of physics or biology who need highly bespoke, hyper-optimized code to run quantum simulations or model protein folding.
Right. These researchers are brilliant physicists, but they are often terrible software engineers.
That makes sense.
They spend months fighting with C++ memory management instead of doing actual science.
So frustrating.
In the 2031 projection, an AI agent acts as a translation layer. It grounds itself in the latest domain-specific scientific literature. The physicist describes the quantum algorithm mathematically.
And the AI.
The AI translates that math into flawless, hardware-optimized code tailored specifically for the architecture of next-generation GPUs or quantum processors. The iteration cycle of human scientific discovery is drastically compressed.
That's going to accelerate everything. Now, use case 4 tackles something I think a lot of mid-sized business owners will resonate with: personalized enterprise tools.
Oh, yeah.
Let's say you run a highly specialized manufacturing plant. Your supply chain has incredibly weird, unique constraints. Today, your only option is to buy a massive, bloated, off-the-shelf SaaS product like a generic ERP system and force your elegant physical manufacturing process to fit the rigid constraints of the software.
And you end up with workers using spreadsheets to bridge all the gaps.
Exactly, because building custom software from scratch is too expensive. But when the marginal cost of generating code approaches zero, that calculation flips. The plant manager simply converses with the AI, describing their exact workflow, the specific machines they use, the peculiar delivery schedules of their vendors.
And the AI builds a bespoke, perfectly tailored supply chain application from scratch.
Software molds to the business rather than the business molding to the software.
It's beautiful, really. And finally, use case 5. Education and open source. We envision AI agents acting as tireless maintainers for critical open source projects.
Which are usually underfunded and overworked.
Constantly. The agents triage bug reports, review human pull requests, explain complex architectural decisions to junior contributors, and effectively multiply the impact of volunteer engineering communities.
It's a comprehensive vision of abundance. But it also introduces a profound shift in what we consider valuable human capital.
It definitely does.
And I see the utopian angle here, I really do. But I have to inject some serious friction into this projection.
Go for it.
If the AI is doing 95% of the heavy lifting, the architecture, the coding, the testing, the deployment, aren't we creating an incredibly fragile world?
How do you mean?
Well, we keep hearing this buzzword vibe coding, right? This idea that you just gesture vaguely at what you want, say, make me a cool website, and the AI magically intuits your desires and builds it.
Right, vibe coding.
But in a purely algorithmic, automated pipeline, doesn't the lack of deep human understanding of the underlying code base become a massive systemic risk?
Oh, I see what you're saying.
Like when the 2031 AI builds a million-line supply chain system, and a year later, a subtle geopolitical shift requires a fundamental change to how tariffs are calculated. Who actually understands the code well enough to verify the AI's updates?
That is the defining vulnerability of the age of abundance. And the source text actually addresses it through the evolution of the engineer.
Okay.
The argument is that the role of the software engineer doesn't disappear. It evolves into AI orchestrator and system thinker.
But practically, what is the difference?
The difference is the level of abstraction. Today, a senior engineer spends a lot of time thinking about syntax, memory allocation, and specific framework quirks.
The nuts and bolts.
Right. The AI orchestrator of 2031 doesn't care about syntax. Their value lies entirely in rigorous boundary definition, system design, and aligning the software with complex, ambiguous human realities. Vibe coding is a myth at the enterprise level. You cannot vibe a banking system into existence.
Right. If you vibe code a banking system, you end up with a system that has great CSS animations, but accidentally deletes accounts when the server clock resets.
Exactly. The demand for talent might actually increase, but the required skill set shifts. As the barrier to entry drops, the sheer volume of software demanded by the world will explode.
Because everyone can make software now.
Yes. We will need an army of orchestrators who can conceptually link a messy business problem like a new tax regulation in 3 different countries to a mathematically precise, verifiable set of constraints that the AI can execute against.
So the AI is the ultimate bricklayer. The human is the city planner who ensures the bridges can hold weight and the roads actually connect the neighborhoods.
That is a perfect way to put it.
So the human contribution moves from execution to intent specification and verification, which is a perfect segue into the final and undoubtedly the most mind-bending section of our deep dive today.
The grand strategy.
Because we have looked at the micro level, a $60 billion code editor. We have looked at the macro level, the 2031 software industry. Now, the Netizen article asks us to zoom out even further, to look at the overarching, almost cosmological philosophy of the people driving this transaction.
It's crucial context. You don't spend $60 billion on a text editor unless it serves a much grander strategic objective.
The day before the Cursor acquisition was finalized, on June 15, 2026, Elon Musk tweeted another statement that the article highlights. It's a statement that makes the Stockfish tweet look modest.
Read it.
He wrote, "Make our sun sentient to understand the universe and extend the light of consciousness to the stars."
It is a staggering statement of purpose.
Truly.
And what the author of the piece does brilliantly is connect this seemingly abstract sci-fi vision directly back to the mechanics of the Cursor acquisition.
Which is hard to see at first glance.
The article frames this deal as a prerequisite for building the world's most useful AI models to usher in the age of abundance.
But let's connect those dots explicitly for the listener. What is the actual tangible link between acquiring an AI code editor for $60 billion and making the sun sentient? On the surface, those two concepts are light years apart.
You have to map out the causality of generalized computer use. Software is no longer just something that lives on a screen. Software is the infrastructure of the physical world.
Right.
Software routes the global supply chain. It manages power grids. It operates autonomous robotic factories.
And crucially for SpaceX, it controls the life support and navigation systems of interplanetary rockets.
So the entity that controls the AI that writes the software effectively controls the nervous system of the future human civilization.
Precisely. If your goal is to extend human consciousness to the stars, to build a self-sustaining colony on Mars, you are operating at the absolute margins of physics. You are dealing with orbital mechanics, radiation shielding, closed-loop, atmospheric scrubbers.
And this brings us all the way back to the Stockfish benchmark.
Yes.
You cannot rely on an AI that is 80% accurate when it is writing the code for a Mars colony's oxygen recycler.
No, absolutely not.
You cannot tolerate an AI that hallucinates a non-existent library when it is calculating the entry trajectory into the Martian atmosphere. You cannot have good enough or vibe coding.
People die.
Exactly. You need true, mathematically provable, superhuman flawlessness. You need Stockfish-level reliability in generalized engineering.
So the SpaceX and Cursor acquisition is a massive, highly calculated bet. The bet is that by monopolizing the ultimate developer interface and feeding it the continuous high-signal telemetry of millions of top-tier human engineers, and backing that interface with the world's largest supercomputer cluster in Colossus, they can brute force their way across that canyon. They can move from 20% accuracy on complex tasks to 99.99% accuracy.
So they aren't just buying a coding tool to help developers build faster mobile apps.
No.
They are buying the foundational engine that will write the code, that will design the machines, that will run the infrastructure required for their entire cosmic ambition. It is a fully vertically integrated vision.
That's terrifying and brilliant.
They own the raw compute, they own the AI models, they own the human interface that trains the models, they own the software output, and they own the rockets that the software flies. cursor is just the lever they grab to start moving the world.
It's the industrial revolution of cognitive labor, packaged into a single corporate transaction.
It really is.
Man, it is a lot to process. Let's take a breath and recap the incredible, sprawling journey we've just taken through this dispatch from 2026.
Let's do it.
We started with the sheer financial audacity of the $60 billion post-IPO acquisition. A brilliant, perhaps ruthless catch-up play by SpaceX to capture the developer interface and monopolize RLHF telemetry.
Yeah, that $10 billion walkaway fee is still blowing my mind.
Same. Then we broke down the mechanics of the stockfish benchmark, exploring why probabilistic language models struggle with the deterministic long-horizon strategy required for massive polyglot codebases.
And we examined the transition from simple autocomplete tools to autonomous agentic workflows, detailing how React loops and human-in-the-loop safeguards attempt to bridge the gap between passing a unit test and achieving true semantic correctness.
Semantic correctness, a term I won't forget anytime soon. Then we looked into the looking glass at 2031, visualizing a world where 95% of production code is AI-generated, legacy COBOL monoliths are migrated in months, solo founders launch complex platforms in days.
And the human role evolves from syntax execution to high-level system orchestration.
Yes. And finally, we trace the causality from a text editor all the way up to the cosmic ambition of building the flawless software infrastructure required for interplanetary expansion.
It is a roadmap of unprecedented disruption, driven by unimaginable capital and computational power.
Which leaves us with a final lingering thought, something for you, the listener, to mull over long after we wrap up today.
Okay, lay it on us.
If this 2031 vision comes to pass, if natural language truly becomes the only programming language you need, and the marginal cost of generating massively complex software plummets to the cost of the electricity required to run the inference, what happens to the inherent value of an idea?
Ooh, that's a deep one.
Right. Because for decades, the barrier to entry has been execution. We value ideas based on how hard they are to build. But when the execution of an idea becomes essentially free and instantaneous, how will you choose to spend your boundless creative bandwidth in the age of abundance? When the friction of creation is removed, what will you build?
It really forces a profound reevaluation of human purpose when the mechanics of creation are just commoditized.
It does. Thank you so much for joining us on this deep dive. Keep questioning the trajectory of the future, keep exploring the mechanics behind the headlines, and remember, the next time you sit down to build something, you might just be one conversation away from the application of your dreams. The steering wheel is right there waiting for you to take hold.